I have my trusty pointer that my wife bought me. Say hi, Harold. Say hi to Harold. Hey, Jeremiah. You can use this as a back scratcher, too. How's everybody doing today? Need to find my pen. I do think you guys would be proud of me. As usual, my desk is a mess. And in typical Mr. Suriani fashion, I'm like, okay, where is the stuff that I'm looking for class? I'm Mr. Nelson. All right. So today, if you didn't join us the other day, you know we've been talking about the steps of the scientific method. Yeah, I actually was at school yesterday, and Mr. Fosnight's domain back there around his desk is the closet and stuff back there. And I was looking for something, and I thought, boy, I wish Mr. Fosnight was here right now, because he knows exactly where everything is back there. And I don't. I know where stuff is in my domain, and he knows where stuff is in his domain. But I did find what I was looking for eventually. Hey, Paul. I think so. I think you do. Here's what I want you guys to do. Let's quickly go through the steps of the scientific method. First thing you do is do what? Somebody type it. I miss you guys too, man. I'm going to have to ride down Britton Road just to see if I can see you riding your bike out there somewhere. Hey, guys, it is okay. It really is okay to be outside. Just remember social distancing. All right. So, what is the first step of the scientific method? Remember that. Hey, Tristan. By the way, I sent out a message this morning that says, remember, you need to get approval on whatever your project's going to be. And you need to do that by either emailing me or private messaging me on Google Classroom. Yeah, the first step is to ask a question. The question is really, what are you trying to solve? Very good. What are you trying to solve? What problem are you trying to solve? I'm going to talk a little bit about that, because I've thought a little bit about some things that you guys can do with one of the things you can do is something with permeability, saturation point. Okay. Those are two examples of something you can do. Does anybody know what permeability means or what saturation point is? While I'm waiting for somebody to answer on that, what is the second part of the scientific method? The third is to make a hypothesis. Okay, there's something in between there. We ask a question, then we do, what's the part where we look things up on a computer? We do our research, really. Saturation point is when something can't hold, well, it might be water, right? And so I actually have a little dish of water, and I have a couple things, at least I did. I have a sponge, and I have a towel. Now, I can put these in the water one at a time, okay? And each one of these is going to have a different saturation point. And so how do you make that into, first of all, how do you measure that? You guys, I'm sure, do not have graduated cylinders or anything like this laying around at home. You probably do have a measuring cup. Most people have some sort of measuring cup. And so a measuring cup is something that you can use to actually do this. So for example, if I wanted to compare the permeability of a sponge to something else, I could actually take this, and let me move it so it's a little bit closer. Okay. How can I measure how much is actually in here? I'm gonna let the excess drip off. I can squeeze as much water out of this, right, as I possibly can, and measure how much I get out of it. The other way I could do it is if I have a specific amount of liquid in a bowl, when I know where my starting point is, you got to remember there's still water in here that we can't measure. The best way to do it is if you start with a certain level. Let's say we started with 200 milliliters, and this absorbed as much water, and then we put the remaining back in there, and there's only 100 milliliters. Then we know that this absorbed 100 milliliters. Okay, so if anybody, so that's one example of absorption, and I'm trying to find a place to put this. It's not going to get everything wet. A saturation point. Do I want you to do it with a sponge? Absolutely not. Because there's probably not going to be a difference between, I mean, usually in a scientific method experiment, you're comparing things, right? Can you look at the saturation point of different things? Absolutely. You could look at the saturation point of types of food. What types of food might absorb water? Rice, pasta, a bean. Yeah, the idea of doing making a volcano was probably the first thing that I said no to, because that's nothing more than an exhibition, right? You're just showing what you can do. This would be something else that you can compare and absorb. So saturation point is just one idea. You have to put your own little twist to it and make it work for you. Let's see where we're at. It could be a saturation point of different types of soils. Think foods, think household items. Don't do anything dangerous. Where am I? Okay, so good medicine. So permeability is the ability of something to pass through a substance. And so could you do a lab where you're checking the permeability of different substances? Yeah, absolutely. Maybe you can check the permeability of some sort of material that you have, whether it be a plastic, whether it be cardboard, paper, something, different things with permeability, on permeability of an egg in different liquids. Is an egg permeable? Does different liquids change the permeability of some sort of food? So remember, you have to have everything the same. You have one variable. The time is going to be the variable thing. And so we've gotten to the point where we're asking a question, we do background research, we construct a hypothesis. You guys have gotten all that to that point, and that's good. At this point, this is where some of the hard work needs to come in. And this is where you guys are going to have to start sending me stuff because what you need to do is create, once you've written a hypothesis, create a materials list. Okay. And so a materials list is going to tell me what exactly you need to do the experiment. And I wish Mr. Fosnight might want to mention something, but if you think about having to do an experiment, he worked in a lab, okay? He might get an experiment that is this thick. He's got to read through all those instructions to get it right. He's got to get it right. And those instructions need to be right. He didn't write them. Somebody else, Harold probably wrote the instructions. Who knows? And he needs to be able to get it right. And the guy who wrote those instructions needs to make sure that he wrote them right. Okay. Mr. Foss and I posted that video about making peanut butter and jelly sandwiches. I hope you guys watched it. I watched it probably 20 times. It still makes me laugh. It should make you guys laugh, and it really should be an eye-opener about really understanding somebody else's instructions and understanding the materials list. What do I need to do an experiment? Do I need something to measure something? In volume, do I need to be able to measure something in length? Do I need to be able to measure something in time? Do I need to be able to weigh something? Which I don't have my scale with me. I brought my scale. Do I need to be able to weigh it? If we're talking about saturation point, do I want to put something on a scale? Do I have a scale? Does somebody in my house have a food scale that weighs in grams and or ounces that I can put something on there and weigh it? I posted stuff this morning. Okay, and so when we could weigh something to especially if we're talking about a little bean or a little piece of pasta or some idea like that, where we're putting it on a scale and we can record that. There's a lot of ways you can look at something, but materials list. What do I need to do it? You literally write the things out. What do I need? Here's something that probably needs to be on the list. Some sort of towels, right, to clean up. Do I need paper so that I can write my results down? Do I need to create a chart so I can record my information? Do I need to make some sort of a chart like this and record my information? You're darn right you probably do. And all that stuff needs to be done, and you need to submit that all to me. And I'm just going to have blank Google Docs, and I did put one on there, and each section is you need to label each section. Here's my question. Here's my hypothesis. Here's my materials list. Here's my procedures. And then you have to have some sort of information where you're charting it. Okay? You're not inventing the wheel, you're not finding a cure for COVID-19, but you're trying to learn something. You guys, that's why I said no volcanoes, because you know what's going to happen. Make this fun, make it about something that you actually would like to learn. And so if you like to cook, make it about cooking. And you can do something about permeability or saturation. Those are just two examples as it involves cooking. You can use household substances, and test different materials in it. How do I do that? Well, if I have maybe glasses, canning jars, or some old glasses that you're not concerned about getting dirty, something that's probably ceramic or glass of some sort. Maybe you can put a solution. Maybe you can put something, if you're testing some object, how does it react in vinegar? And I'm not talking about baking soda. I'm talking about a food. I'm talking about some sort of metal, and test it in different substances. Maybe you're trying to get a stain out. Maybe you've got something that's stained beyond repair, and it's ready for the trash can. I'll give you an F if you. I won't even go there. All right, so if you got something that's really stained, maybe you were eating spaghetti and it fell on your shirt because your mouth isn't big enough. Maybe you're out playing and you gotta. So I mean, you can actually, if it's ruined and you're not going to wear it anymore, if it's bad enough, you can cut out some various pieces of that stain, put it in different solutions, see what works. And so you're going to test them, different solutions, same amount of time. How quickly does it come clean? How quickly does it come clean? How quickly does it get clean? And so you could measure it. You can observe it 2 times a day, once a day. Is it, for 7 days, is it going to come clean at all, or is it not? How many solutions do you want to do? Do you want to do 2, 3, 4? And so you can things there. And so I'm trying to get you guys to be creative. Remember, you've got to get approval on your experiment before you do it. So you need to email me or private message me on Google Classroom, and I'll say yay or nay. We're not doing volcanoes. Forget about it. You are all much smarter than that. And again, I want it to be something that you can learn. If you get to a point where you can't figure something out, because I know I'm going to hear, I can imagine at least 1 or 2 people that I know are going to say, Mr. Suriani, I can't think of anything. I won't mention any names. Mr. Fosnight will probably text me who he thinks is going to be that, and we'll laugh about it. We'll laugh about it if we're right. Anyways, those things, that materials list needs to be in place, okay? What do I need for that experiment? Do I need to record the time? All those things, you need to make a list. I'm going to look at it and I'm going to say, yeah, this is good, or hey, you're forgetting this. Your procedures, watch that peanut butter and jelly. Watch that peanut butter and jelly video, okay? And so it's going to make the point of doing your procedures properly. Don't say, get your materials together, do the experiment. Okay, how do I do the experiment? Remember, step, step, step. Take the liquid in the measuring cup. If you don't have this, right, you got measuring cups, and pour it in. Pour an equal amount in each jar, right? That's after you've placed whatever you're placing in. Each thing you have to really write it out. It'll be a little bit painful for you guys that don't like to write. It's probably the most painful step, but you'll learn something about yourself. You'll learn about your communication ability. A lot of times you guys are more verbal than you realize, and you could figure these things out. And so expect me to say, this is where the most corrections are going to be, is going to be in the procedures part. Expect me to say, I don't know what to do here. You have to write the experiment as if you're writing the experiment for somebody who has never done an experiment before. Yeah, I posted a doc, and so your doc, and I'll get to that in a second, Nathaniel. You have to write the experiment as if you're writing it for somebody that has never done an experiment in their life. Don't expect that person to have the lab experience to know generally how to do it. Write it as if the person has never done one before, and so you need to tell them every step of what you need to do. That's what I expect from you guys. There is a Google Doc that I posted. I'll make sure it's there, that you do every step. You put your what your experiment is about. I give you approval. Okay. You do your background research and write your hypothesis. When you write a hypothesis, you say, this is what I expect to happen. But I'm going to have you guys add something in there, okay? It's part of your background research. How do you know or why do you think that your hypothesis is going to work? Is it because of something that you know? Is it because of something that you looked up? Is it because of something that somebody else said to you? Remember, background knowledge can come from your own knowledge, from an expert, from your choose or an expert, or it's something that you research. So your hypothesis has to be based on what you know, and so you have to what's the word, not categorize, but you have to say, I think this is what's going to happen because this is what I learned in my background research. The idea of what you're supposed to be doing in your project is, Madison, is you need to get approval. It can be anything about anything, but it needs to be a project, a scientific method project where you're doing research and not a exhibition. You guys, that's why I said the volcano thing is not appropriate. We all know what's going to happen. We mix the two together. I've done it in class. Okay. That would be an exhibition where you're just showing me that you can mix two chemicals together. What I want you guys to do is say, I want to learn something about something. If you like to cook, you can do it in the cooking realm. If you like to create things, I don't care what it is across the spectrum. It could be anything that you can think of, but I want you, if it's something that you find, if it's an idea that you find online, put a twist on it so that it becomes unique and that you're going to learn something. And I hope that helps. Now, Kashan, I know you're there and you've asked the same question 3 times. I do want you to do something else. I've said 3 times that volcanoes are out, and so that you're going to be doing something differently. So what Mr. Fosnight is talking about when he says no one will be right the first time, when you do your procedures list, your instructions list, no one is going to be right. You're just not. You're going to forget something somewhere. I might even read through it and say it's okay. And when you go to do, when you actually go through to do the experiment, I might say it's okay. It looks pretty good. Go ahead and try it. You might go through the experiment and go, oh crap, I forgot to do this step. So even though I thought it was okay and Mr. Suriani thought it was okay, that experiment might still, you might realize that you missed a step. What are you going to do? If you do that, if you do the experiment and you realize that you missed a step, you go back up to your procedures, you type in the step that you missed in a different color. So if you typed in everything in black, which is what I want you to do, and you realize you missed a step, you go back in and add that step in red or blue or green, something that a bright color that I can read. And so I can go back in and say, see, they learned that they missed a step. They figured that out. They're going to go back into their procedures and add that in. All right. So anybody have any questions at this point? Okay. And please ask them, because I didn't realize how late it is time-wise. And don't be afraid. I expect a lot of questions in this. You need to get approval from me before you do an experiment. So anybody that says they've done it already, it's moot anyways. Here's another thing I want you to do. Be prepared to take pictures with your phone, your mom. If you don't have a phone, your mom or your grandmother, your aunt or uncle or sister or brother, or somebody has a phone, take a couple pictures of your experiment and email them to me so that I can see how it's going. I want to see it. I want to see it written. I want to see it visually. That's what I expect. And you guys can do this, and I think you can have a lot of fun with it. Okay. And I need to get off because somebody else is getting on to record or live stream. And so you guys have a good day. Don't forget to say goodbye to Mr. Harold. Madison, you always remember. You can't forget about Harold. And just a note, I'm going to be posting some videos from my YouTube channel just for the fun of it, so you guys have something cool to watch. My YouTube channel is my name, Thomas Suriani. You can look stuff up there too. Take care. Bye-bye.